All right, I think I'm back. All right, so welcome back to the stream. If you caught me yesterday or have seen the replay of yesterday's stream, basically I'm doing a 60-hour bet with one of my friends that I could stream for 60 hours, doing coding stuff, programming stuff, learning stuff. I don't know. We'll see what we do. Anyway, so yesterday I did 3 hours, and we built a timer to go up from, what was it? To go from 0 all the way up to 60 hours. The app I was using didn't have the best way to do that. Let's see. He just very funny, Dave. So I created my own. Little JavaScript app that will allow me to basically start my timer from 3 hours, 1 minute, and 32 seconds, which is what it finished at yesterday. So let me go into my directory. So let's start the, what's this called? I named it hello.txt. I mean, that was just the name of the text file that it's reading from right now. And the name of the JavaScript app that I wrote is count up timer. So if I just run this in my terminal, we should start seeing the timer at the bottom incrementing, going up every second. All right, so we're good. I could minimize this. It should keep going even when minimized, unlike the other app that I was using. And I can close out of this. Now I got to think about what I'm going to do today. Dave, can you hear me? Is my sound good? The video good? Everything okay? The quality? I know you might be like about 15 seconds behind me, so let me open up a Safari and we'll try to figure out what we're going to do today. Okay, good. I really didn't plan anything for today, so I don't know what to build. Maybe we'll try one of the curricula that I know that our team uses. So let's see, blueprint.csforall.nyc. I always keep hearing people talking about p5.js, which is a JavaScript library. Let me actually pull up a tab here. p5.js. I know that the coding train dude does a lot of stuff. He likes p5. So it's a JavaScript library for creative coding. I've probably looked at this page for like 10 seconds in my entire life. So I really haven't done any p5. So maybe I'll do that today. Maybe I'll focus on p5, seeing what is actually being done in p5. So hold on, I'm getting texts over here. This is a birthday stream, so I keep getting texts. Okay, I keep getting texts from some people that I know, but that's all right. All right, so it's a JavaScript library for creative coding with a focus on making coding accessible for blah, blah, blah. It's free and open source. Using the metaphor of a sketch, p5 is a full set of drawing functionality. However, you're not limited to the drawing canvas. You can think of your whole browser page as a sketch, including HTML5 objects for text input, video, webcam, and sound. Let's start creating. Let me open up a new tab and get the web editor going over there. There's a community. Okay. Make your first sketch in the p5.js editor. Learn more about sketching with p5.js on the Get Started page and everything you can do in the reference. We'll open up the Get Started page. I'll also open up the reference just so we could look at that if we get stuck, if we're trying to figure out how to do something. Let's see. Oh, actually, right now you can't really see the timer, but I assure you that it's there. So when I switch over to another, like a dark background website, you'll be able to see it. Okay. Let's see. All right, let's go to the Get Started page and see what we can do with p5.js. This page walks you through setting up a p5.js project, making your own first sketch. The easiest way is to start using the editor. You can open the web editor and can scroll down to your first sketch. If you would like to work on the desktop version, you could scroll down to downloading instructions. Let's use the web editor just to keep everything simple. So we have a function setup and a function draw. And this, I guess, sets up the canvas that we're going to be able to see our, the effects of our code in. After background 220. Include this line of code, ellipse. Now your code should look like this. Let me go to the web editor. So after background, let me type in that ellipse. Okay, let me run that code. And we have a, looks like a circle. Let's see what else. The line you just added draws an ellipse with its center 50 pixels over from the left, 50 down, with a width and a height of 80 pixels. So we just drew a circle. But we could make it more, I guess, oval shaped if we just, play around with the numbers, change it a little bit, and then hit run. So maybe I got to move it over. So is X, so X, we want to move X over a little bit, so maybe we'll make that 80. There we go, so it fits in my preview. We'll move it down 80 also, so it kind of looks a little bit more even, maybe. Actually, it doesn't really look that great, but whatever. All right, so we have an ellipse. This is how you draw an ellipse. We could create a bigger canvas, I'm assuming, by changing these arguments. Yeah, so I can make it 500 by 500. Okay, interesting. Let's see. Press play to display your code in action. If you're using a screen reader, this will appear in the display below. If nothing appears, this editor may be having trouble understanding what you've typed. If this happens, make sure you've copied the example code exactly. The number should be contained within parentheses, okay? Yeah, because those are functions. One of the most difficult things about getting started with programming is that you have to be very specific about the syntax. The browser isn't always smart enough to know what you mean. And it can be quite fussy about the placement of punctuation. You'll get used to it with a little practice. In the bottom left of the editor, you'll find the console. Did I see that? Yeah, down here in the bottom left, I could see the console. Let's see what else. You can find messages from the editor with any errors. We'll skip ahead to the sketch that's a little bit more exciting. Modify the last example to try this. So let's modify it to have this conditional inside of the draw function. There we go. So let me press the run. And now it is drawing. So if the mouse, how does this work? If mouse is pressed, so if I press it, okay, it fills up the color. It changes, I guess fill 0 makes it all black, fills in the entire color. Otherwise, it just fills it with 255, so that must be, I guess, white. Oh, and the ellipse, okay, so the way that it's drawing the ellipse, it's looking at my mouse X, mouse Y coordinates, and it's just constantly updating it. So it's just basically following the mouse. And I guess it's running through this over and over again. So I can hold down the mouse button and then move it around. Okay, so that's pretty cool. This project creates a canvas that is 400 pixels wide. Oh, let me go back to 400 by 400 because I was at 500, 500. You run that again. But it doesn't really have a trail like the one that shows there. When the mouse button is pressed, the circle color changes to black. Run the code, move the mouse, and click to experience it. So mine isn't really drawing a trail like this. Why is that? Oh, you know why? Because I have background here. So I guess mine is just constantly repainting the background. So that way you don't see like the trail. But I guess if I cancel out this line or comment it out and hit run, there we go. Now it's creating a trail of the thing that I'm doing. And if I hold down the mouse, if I press down on the mouse button, it's turning black. So you could easily see that. So that's pretty cool. Very visual. I kind of like how visual it looks. Awesome, awesome. Okay, so let me just stop that. Oh, stopping it clears off the canvas. Let's see what else. What next? Check out the Learn page, the example page, watch the coding train, view the reference for full documentation, blah, blah, blah. Okay, I don't really care about running it on my own computer like right now, so I'm just gonna ignore that. All right, let's look at the reference. Okay, so there's a whole bunch of functions here that are already available for us. Is there anything with, let me see what events they're detecting. So they could detect the key presses the mouse, double clicking, the mouse wheel being used. If we rotate something, maybe an image or something. Down here we have some things for images. We could load an image inside of there. Okay. Actually, what does that look like? So we could preload an image from a JPEG and then throw it in, draw it on the canvas. And create a p5 image from it. Okay. All right, what else is there in the reference? We have some constants that are already in there built in. I guess we could mess around with the DOM. So we could put some DOM elements on the canvas. So it'll look like maybe like a web page with like radio buttons or something, or sliders. So we could do something like that. So you could start creating some pretty interesting things actually with some of these elements, like a checkbox thing, color picker, an input. You can get user input. Okay, so there's a lot to do with this. In the foundation, we have let, const, we have the operators, we have conditionals, booleans, strings, numbers. Okay, whole bunch of stuff we could do here, and stuff to render it onto the screen on the canvas. Okay, there's a whole bunch. Wow, we could actually access local storage, so maybe we could save things on someone's browser, basically in like the storage container for the browser. We could do that. Wow, there's a lot to do with p5. I haven't played around with any of this, but it looks pretty interesting. I'd like to see some like real projects. I guess I'll go back to where it says check out the examples. Where did it say that? In the get started, there was something with an example. Examples page. Let me see some examples of things that people have created. Let's go with, let's look at forces. Simulate forces. Okay, so interesting. So it's like almost like gravity over here. Well, let me run that again. How do I run it again? I just press run. So all the way up until it reaches the bottom, it looks like there's like it looks like they're in a vacuum in the light gray, because all of them are dropping at the same looks like the same rate. But once they hit the this dark gray, it looks like they meet some like air resistance or something. So the bigger ones drop a little bit faster than the smaller ones, almost like real life here. Oh, it's supposed to represent the liquid. Okay, so they create the canvas. I wonder what this reset does, the reset function. Maybe from the if there's like a previous run, it just clears off everything that's in there, probably. Create a liquid object. So this is how they create this liquid. All right. If the mover is in the liquid, they calculate the drag. So they apply a force of a drag so that it doesn't drop as fast. And then they apply gravity. Is gravity built in? Let me see. Gravity. Or is it calculated somewhere? All right, how do I close out of this search? That's fine. Oh, here we go. Let gravity equals create vector. All right, so this is how they're simulating gravity, I guess, based on the mass of the object. Wow, this is pretty advanced stuff. For something so, I mean, it obviously looks simple, but it's definitely not simple. But it just, I guess, it goes to show the power of p5. What else is there? Let's look at another example. Let's see. Brownie in motion. So I did something a few months ago that kind of simulated Brownie in motion, where I had some particles like moving around randomly. Looks like this one's doing the same thing. Recording random movement as a continuous line. So we have this little tiny, I mean, I guess pencil you could call it, and it's just drawing randomly on the screen. Really interesting. Okay. Advanced stuff. I did not expect such things. Kaleidoscope. Pointillism by Dan Schiffman. Okay. Mouse. Horizontal location controls the size of dots. So when I move my, let me reset this. When I move my mouse to the left, it makes smaller dots. When I move it all the way to the right, it makes bigger dots. It's pretty cool. And you can see the code that allows for that. So just go into like a random position, I guess. Pointillize. Interesting. All right, so because these are just examples and I have no idea what I'm going to do with this, why don't we look at a curriculum that maybe I could follow and do something with P5 just to get some experience with it. So I know that the NYC DOE has some curriculum that uses P5. Just got to find it. It might be this creative computing. All right, it's not the physical computing. That would be like robots or robotics. Introduction to computational media. So it might be this, or it might be the creative computing. So let me open both of these up, and I'll figure out which of these might be the curriculum that I'm looking for. What are the odds? Here we go. Introduction to computational media. Let me just see what the other creative computing one was. It's using Scratch. All right, so I don't want to use Scratch today. I want to use this P5 and get some experience with this one. So let me look at the curriculum. Here we go. Let me just close out of everything else. I'll leave the web editor open, obviously. And let's see what we have to do in the computational media with p5.js curriculum. Okay, so sorry about the timer. Once again, like you're not going to be able to see the timer because, here, let me bring my terminal over. Because it's being covered, or you can't see it on a white background. But it's still going. So we're at 3 hours, 17 minutes, 50 seconds as of right now. And so that's just going to keep going as long as the terminal window's open. So just got to make sure that that doesn't get closed ever. Okay, so let's see. This is the teacher-facing P5 curriculum. I don't want to see the teacher-facing one. I want to see the student-facing one. But I guess we'll just go through the lessons and figure out what the students would see from this. So let me open up Lab 1, Create a Grayscale Drawing. Introduction and Deconstruction. We'll start with that. We'll start with that. How can we break down a robot into basic shapes in P5.js? Oh, I wonder how teachers are presenting this to their students. So this is what a teacher would look at, but where's the student-facing one? It's going to be a little tricky. Is this it, or is this just opening up the... No, it's another like lesson plan. So I don't really want to see the teacher-facing side. I want to see the student side. I don't know what that's where that is. I guess maybe teachers are supposed to create their own like student-facing side from the lesson plan. This looks like kind of like a lesson plan, so students will be able to create an account on the editor, explain what P5 is, describe things you can create, understand the Canvas coordinate system. Okay, we have some vocabulary. Let's see. Give examples of specific patterns in something I can see, do, or touch. Describe different things I tried. Explain how I might help others identify patterns. Explain why I use specific instructions to complete a task. Compare and contrast my instructions with other instructions that complete the same task. All right, let's see. We have some vocabulary. So the important ones here, definitely abstraction is really important. the process of taking away or removing characteristics from something in order to reduce it to a set of essential characteristics. So an example of that is if I was asked you to guess the movie that I'm thinking about right now, and I said an unsinkable ship sinks, I think pretty much everyone would know what movie I'm talking about. Hopefully you know what movie I'm talking about. But that is an example of abstraction. I took away the main concept of the movie, shortened it down to like a sentence, and now I'm telling you the sentence and you could identify the movie from that. Okay, height, width, radius, diameter, Cartesian plane, place, or plane. It's all good. Okay. In this course, we're going to make projects using P5. Watch this video and see for yourself what kind of projects you can make. I don't really want to spend time watching a video. I want to actually do some coding. So let me see some activity let's see some instructions that I need to follow. Okay, so this would be something that I would do on paper first. You will use a graph that has a p5.js coordinate system to draw out a design. Write down instructions on how another person could draw them. Use only two types of shapes, ellipses and rectangles. So draw a robot using basic shapes. Okay, so this is I would do this on paper. I would draw a rectangle that would represent the robot, and maybe some circles that would represent, or ellipses that would represent its eyes, I guess. And this is explaining to the teacher how the coordinate system works in P5.js. So the students, when we're in class, or when students are in school, they're learning this left side, where they go from negative x to positive x, negative y to positive y. But on the computer, the top left is 0, 0. And so I guess the first value would be the x along the x-axis. We're moving from the left side. And then the y will be moving down from the top. So that's how the computer, I guess, is going to be. That's how we're going to use our coordinate system on the computer. So if we want to have a circle in the bottom right, it's going to have to be 6, 6 inside of the computer if we're using P5.js. Okay, so for this robot, we have a rectangle and we have a few rectangles. We even have a square here too. So we have 1, 2, 3 rectangles, because a square is a rectangle, and 2 ellipses, or 2 circles here, because these are perfect circles. Okay, so I guess maybe we could try to draw this in P5. I wonder what it goes, actually, I was going to say I wonder what number it goes up to, but it's definitely going to be up to 400. So let's draw a square first. First we got to draw a background, actually. So there's my background. So let's draw a square. That was ellipse. And let's have it directly in the center. You remove some of these comments. Let's have this directly in the center. So that's going to be 200, 200. And actually, how did that work again? How do we use ellipse in P5? Let me just open up a new P5.js ellipse. So the x and y coordinate, the width and the height. So let's go with 100 by 100. And that should give us a circle right in the middle. Okay. Let's see, what else? Oh, but I don't want an ellipse. I want a rectangle. So how do we draw a rectangle in P5? All right, so let's see. Let's go back to the reference and let's see if we could search for rectangle. Maybe it's going to be rect. Okay, so rect is going to be our rectangle. We could put the location and then the width and the height. Okay, so let me comment out the circle and just draw a rectangle at 200, so it's going to be in the center. 200 by 200, and then the width is going to be, let's not do 55, let's do, actually, is that how it's, why isn't it completely centered? Oh, so maybe the leftmost point is the center. Okay, so I got to be very careful here. Okay, so now I'm going to have to think a little bit harder. So let's say that the rectangle I'm drawing is 100 by 100, right? So that means I have to shift it over along the x by 50, I guess. So instead of 200, I'll make it 150, and that'll move it to the left. And if I want to center it, I got to move it up now by 50 also. So instead of 200, let's go with 150. What's up, Mark? It works in the left corner. You have the top left corner is where it's I think starting from for the rectangle. You have to change Rect Mode to center. Oh, okay. Have you used P5 before, Mark? I'm curious when you used it. Yeah, Rect Mode. So right now it's in corner, but I don't want it to be in corner. I want it to be in center, so it's just easier to think about. So then, now I can go back to 200, 200. There we go. Okay, let me make that a little bit bigger. Let's go 200 by 200. So this is going to be a big square over here. There we go. Okay, what's next? So we're going to try to draw two circles inside of this giant square. So we could use the ellipse. And now we got to think about where we want to put the circles. So we can go maybe, so 200 would be about here. So maybe 170-ish along the x, 170, and then along the y, 200, let's try 150. And let's make it smaller. 100 is just a little bit too big. So let's go, it's probably too big. Let's go 80 by 80. And there we have one circle. It's a little bit too big still. Let's go 50 by 50. Yeah, I've used P5 through the past. What have you been using it? Like, was there a reason you were using P5? Did you like stumble upon it or find like a YouTube video, or are you doing something like with P5 specifically? Let's add another circle. So we'll create another ellipse, but we'll just move it along the x-axis a little bit. So instead of 170, we'll do 230. So this should be like on the opposite side. There we go. So we're getting our robot. We have its eyes. What else do we need? All right, we need a rectangle for its mouth. So we need another rect. And that is going to be, let's see. I think Rect Mode Center will make it so that we can just center it. So we'll be able to identify the center of the rectangle. So let's go with, let's see, that'll be like 200-ish, a little bit below. So in the center of the x-axis, so 200, and then below the center, so we'll go, let's say 240, and we'll create a width of, let's say 120, and a height of, let's say 50. So hopefully this should create a rectangle that we want. Yes, there we go. The program I was in used it. We used the Glitch IDE. I have not heard of Glitch. What is the Glitch IDE? Simple, powerful, free tools. Glitch is a friendly community where everyone codes together. Never heard of this. How does this work? Glitch for devs. Let me see. Actually, I have heard of glitch. I used it one time when someone was showing me how to do like 3D objects in, someone was using, I can't remember what it was called. What was it called? They were using like 3D objects in JavaScript. And I think they were using glitch to share that project so that people could use it. But I cannot remember what it was called for the life of me. But yeah, I remember glitch. I don't know what's going on with this load project. There we go. Yeah, it looks like it's, yeah, it was like, it's like an online IDE, so you don't have to like download like VS Code or Sublime or anything. Pretty cool. Yeah, I used this one time and I cannot remember what it was called. If I ever remember, I'll mention it again. All right, and so now last thing I need to do is put a little square on top of the robot's head. So that's going to be another rect, and that's going to be at 200 on the x-axis. Okay, let's see, how far down should we go? I guess it depends on the height of the rectangle that we're creating. It's really good for group work. You can work on it at once, like a Google Doc. Ooh, that's interesting. Learning web development. Oh, that is really interesting. If you could have multiple people working in the same IDE, basically, that's actually really interesting. Hold on, this is going to drive me nuts if I don't remember. JavaScript, 3D objects. What was it called? No, it wasn't 3. Definitely was not this. Although this looks pretty cool. Some like VR thing that you could check out. Let's let it load. It takes a second, more than a second. As I mentioned on yesterday's stream, this computer is it's dying. Actually, great news! I bought a new computer a few hours ago. So I decided to just pull the trigger. Apple updated their iMacs, so I just decided to pull the trigger and buy one. And I'll probably just give it to my girlfriend in a year or two when like the newer ones come out. Hopefully she doesn't hear that or get offended by it. But yeah, so I bought the iMac that looks, I mean, here, I'll show you. They didn't change anything of like in terms of looks. They just, and probably because this is going to be the last one with the Intel processors. So I ended up picking up one of these bad boys. So it's going to take a couple of weeks for it to get here, but I mean by then it's almost the end of the stream. Such an ugly computer. I mean, it's like, it's so dated, but what are you going to do? But I got a pretty powerful one, so we'll see how it runs. My MacBook Pro right now is like, it's about to like light on fire, so hopefully it'll, yeah, I mean, this thing should not be taking this long to load. I don't know what is going on. I mean, unless the projects are like really, really crazy. Maybe it's stuck? I mean, I don't think so. It's hard to tell. All right, this one's almost done loading. 99, 100%. I mean, this looks amazing. Although it's going at like 2 frames a second because probably because of my computer. If this is done in JavaScript somehow, that is just insane. Let me click on the editor and see what this looks like. So I can change what's coming off of this like screen looking thing. That is not 60 frames per second. That's a lie. Model person, what about a car? That is so cool looking. But it is not running at 60 frames per second, that's a lie. Personal shader playground. All right, hold on. We're getting off topic here. I don't know what this one's doing, so I'm just gonna close it. I don't remember what the 3D thing that I was using was. JavaScript 3D manipulation. What was it called? It wasn't D3. I cannot remember. All right, so let me close that. But I remember seeing glitch because that's how he shared the code with us, and then we were all able to modify it. He had the JavaScript inside of the HTML, and we were able to play around with change the JavaScript a little bit, and then be able to see the 3D objects on screen. If it was something with 3D objects, you can look in the P5 reference under 3D primitives. Oh, so P5 can do 3D also? Let me look at that. Let me look that up. I want to see some examples of the 2D primitives, 3D. Okay, here we go. Box. Oh, wow, that's interesting. Can I just throw this in my thing right here? Hold on. Let me finish this tiny little square hat thing that I got to put on this thing. It's going to be 200 along the x and along the y-axis. So along that, we're going to move it down. What would it be? I guess it depends on the height of the square. If we make the square, let's say 60, so width, let's do width, height 60, 60, but we need to know how far down we should bring it. So if I just guess right now, let me just put 180, see where that ends up. So yeah, that's way too far down. So let's make it 120, too high. Ooh, because I did 12. Let me change that to 120. Okay, it's not high enough. Let's make it 80. Right now we're just guessing and hoping to get close enough. 80 will work if I make this 50, I think. So if I make the square a little bit smaller, actually no, not 50, 70. Nope, let me move it down a little bit more, 75, that should be it. There we go. So now we have that square. We've recreated this robot face looking thing, or something close to it. Now let me see what happens if I throw in the code for that box, and then I press play. Now we have an error. I guess we can't use it like this. Maybe we have to like import some other library or something. Oh, we have to bring Webgl into the setup. Let's try it. Let's see what happens. Create canvas Webgl. Does that screw up my? Yeah, it changes the way that this is going to show up. All right, let's just run this. There we go. Oh, that is so cool. That is really interesting. I guess this is going to be the size of the box. If I can make it a little bit bigger. Yep. Cool. Okay. Let me go back to normal mode because we're just using P5 for the first time over here. So I finally got my robot face showing up. All right, let's move the eyes. They look a little too close. Let's make this 160 and 240 to separate the eyes just a little bit. There we go. All right, that looks more normal, I guess, for a robot. Okay, so what's next? Okay, so I used all these things. I did all these things. Okay, I guess we finished lesson 1, which was to understand the coordinate system of P5 by drawing a robot's face using rectangles and ellipses. Find a partner and add one feature to their robot and have them deconstruct the position and the size of the new feature. So if I added something to this robot, my partner would try to figure out exactly what I did, or what the coordinates were, the inputs that I passed to the function. But I don't have a partner right now, so I'm just gonna keep going. We're gonna keep trucking over here. Create a symbol that's meaningful to you. All right, that's a little bit too deep. We'll skip that. But I think I could create a symbol. Do I really want to do that right now? Now I kind of just want to keep learning what else I could do with P5, because that 3D stuff looks really cool. And write a short paragraph. Who's got time for that right now, right? All right, so that was lesson 1 from unit 1. Okay, so let's go on to the second lesson. Let me close this out. Let's go to the second lesson, which is line functions and parameters. Should take 45 minutes. I mean, if you know, I was a student or if I was a teacher teaching this to a bunch of students, we would go through this a lot slower, and we would actually do all of the activities and, you know, write things out, draw things out. But since I'm just like blasting through it, trying to learn it, experience it for the first time, I don't really care too much about the about making sure I know what I'm doing here. You know what I'm going to do? Because the background here is like white, I'm going to change the, let me go to my count up. I'm going to change the properties of my timer. So this is the timer that I created yesterday. Let's, can we make it not white? Okay, here we go. Let's make it black. So let's make it 0, 0, 0. Oh, give it a nice little like, kind of like fade thing or gradient, but I don't really care about having a gradient. I just want it all black because today's screen is it's just white. So there we go. So we have our timer going in the bottom right, the one that we created yesterday. We continued from like 3 hours, 1 minute, and a certain number of seconds. And now you can see it. Okay, let's see. So in this lesson, lesson 2, we're supposed to understand the P5 canvas coordinate system, consult the reference, create a line and a point, change the grayscale values of a canvas, and use lines to create a rectangle or a house. So instead of using a rect function, we're going to use a line, or 4 lines, I'm assuming, to create a rectangle or a house. For abstraction, give examples of specific patterns. So yeah, so another way to think of abstractions is like pattern recognition. Describe different things I tried in order to achieve a goal. Explain how I might help others identify patterns. Describe more than one set of instructions. Okay, so these are the computer science concepts and like what we should be getting out of this lesson. So this is like for the teacher. This is for the teacher to be able to like identify what they want to like maybe assess from their students or try to identify from their students to see if their students are understanding or able to describe like, you know, algorithms or, you know, what they're programming. But I don't really need to read through all that. I just need to get to the task or whatever it is. And there's some vocabulary here. So I actually kind of like this. Although I don't think this is the student-facing thing. I think some teachers would share this with their students. We have our reference. We already have it open. Line worksheet. What's this look like? Okay. Oh, cool. So this is the canvas. This is what the canvas looks like. So if we're drawing a line from 120, 120 to 220, 60. That's what it would look like. Okay. Well, we'll have to figure out how to do lines in a few minutes. So I think this is just identifying maybe the start and end points for these lines. So you should be able to, draw the line and identify the coordinates that would lead to the creation of that line. All right, so this is fine. What's next? The P5 alpha editor is a web-based code editor. Wait, is this different than the one I'm using? Let me open this up. No, it's the web editor. It's fine. Same exact thing that I had open. I'm going to close my rectangle, my robot thing. Say goodbye. Okay, so we're back at this. Draw an ellipse 200, 250. So ellipse 200, 250. So that's going to be right in the center with a 50 diameter. A diameter of 50 pixels, I'm assuming. Okay, when creating a new sketch, it will populate the file with some basic starter code. The window can be used like a typical text editor. Okay. To the right of the text editor is the preview. This is actually a window with the website, with the website being created and the editor embedded inside of it. When the sketch is executed, the result will appear in the preview window. So yeah, everything we look at is here on the right side in the preview. Kind of like Scratch or Snap, if you've ever used either one. We have the stage on the right side. Over here, it's just called the preview. We have all our code on the left side. Okay. So we're just learning how to, navigate this interface and figure out how to do stuff. And then we have the console window in the bottom left, which is always nice. So we could run we could put like a console.log hello, and we should be able to see that when we run it in the console. There we go. Why is it happening over? Oh, you know what? I think it's because it's constantly drawing. So this function is just constantly being run, I think. Let me just comment that out. Otherwise, it's just going to keep saying hello multiple times. So that we have the play button, the stop button for the text editor. It'll run the sketch. So yeah, when you hit run, I guess it's just going to keep running that draw function. Right? The draw function. The sketch can also be run by hitting Command Enter on the Mac, and stopped with Command Shift Enter, or return. And I could save the stuff, but I don't have an account, so I'm not really worried about that right now. Let me see something. There's also, there's some shortcuts. You have a tidy button. Tidy code updates the code formatting. It does the indentation. Oh, so that's nice. How do you do that? Shift tab. Okay, so Shift tab is a way to make the code nice. So for example, if you've got your code all screwed up with the indentations, I think if I hit Shift tab, it indents everything correctly. Perfect. So that's going to come in handy. If I have feedback, I don't have feedback. What else? Settings. Ooh, there's a settings button. Where is that? Oh, here the gear in the top right. We could do maybe the dark mode. That looks actually kind of nice. But now I can't see my timer, so I'm going to go back to light. Let's see. Text size, 18 is fine. High contrast. All right, so this is fine. We'll just leave the settings how they are. Code is just a set of instructions for the computer. In order to give instructions to p5, we need to use different functions to change our parameters to fit our desired outputs. I think we should change the arguments that we pass in to fit the outputs. Okay, we have functions. Actually, now that I think about it, this is probably for someone who's never coded before. For students that are just learning how to code and just learning JavaScript. So this is actually probably a little bit advanced for lesson 2 for students. Maybe it's not so bad. Maybe if you've never used JavaScript before, you could kind of understand that, function setup sets up the canvas if you put create canvas inside there with some numbers in the parentheses. Let's see. Create canvas. The function creates a p5 canvas. Okay, so I got all that. I understand all that. I kind of like that this was hand drawn actually. The background gives a background grayscale color between 0, which is black, and 255, which is white. Okay, so right now I think it's at 220. So if I run this, it's just a gray background. But if I get closer to 0, so if I do 100, it's going to be a little bit darker. Yes. And 0 would be perfectly black. Let's see what else. What happens if you were to add multiple background functions with different values? What happens if you were to add, it's a little tricky to understand, which of background color is prioritized? Why? Oh, so I think they're trying to ask what would happen if I did multiple background functions. So if I ran background multiple times, Let's see what happens. So what happens if I do, 100 and then 200 underneath it? Okay, so it goes to the lighter one. Let's reverse the order, and it should be darker. Okay, so I guess it's the bottommost one that we'll actually see displayed. So let's go back to 100. So it's a little bit darker. Which of the background colors is prioritized? The bottom one, probably because we're reading from top to bottom. We're reading code from top to bottom. To draw on the canvas, call p5 functions like point and line. So we have a line function that we're going to want to use. A point is defined by an x, y coordinate. Okay, that's fine. And the line is defined by its start and end points. So that is, yes, here we go. So line is x1, y1, x2, y2. Perfect. Okay, so here I could just copy and paste this code inside of my web editor. So instead of drawing an ellipse, or underneath the ellipse, we're going to draw a line that goes from 300, comma 20. So it should be up here somewhere. 300 is like right around here, and 20 is like right over here. And it's going to draw it to 400, comma 100. So it's going to be a line, I think, going like this. Yep. So that looks about right. That's what I expected, which is what they want us to be able to do. They want us to be able to like look at the code and predict what's going to happen in the preview. Okay. As you can see, the lines with a double backslash, forward slash before them are grayed out. So these are comments. That's how you comment in JavaScript. If you did not know that, or if you didn't notice me doing that, if I wanted to comment out this ellipse, if I don't want to delete the code, but I want to like have, the browser ignore the ellipse function, I could just do the double forward slash, and then when I rerun it, the ellipse is gone. So the code's still there, but it's being ignored because it's a comment now. Okay, so that's great. Let's see. Programmers add comments to their code as notes to themselves or others who might be reading it. Yep. Commenting code is excellent practice and should be constantly encouraged. Yes. Although I would add a caveat to that. I would say that your code should be able to be read by anyone that's reading it and understood by anyone that's reading it. So this is kind of like a contentious thing, or like people debate this all the time, whether you should make your code really short, like if the goal is to be as short and concise as possible, or to be as readable as possible. And I happen to think that you should be able to read it and understand what's going on. It shouldn't just be all like, shortcuts and like random variable, using var a equals 54 instead of var, length equals 54. So use code variable names and code that actually is more readable. So even though these two do the same thing and line 11 is a little bit shorter, I would say go with line 12 because you want someone reading the code to be able to understand what this variable represents. They just see A, B, C's, and letters all over the place. They're not going to understand it. Okay, so here's our practice. Draw a point near the top right corner of the canvas. Draw a point in the middle of the canvas. Okay, so let us do point. So point is just XY. So let me comment out that line. For the point, if we want to be at the top right, we're going to be at close to 400. Let's try 400. And then close to 0, because we want to be closer to the top. Let's see what that looks like, or if we could even see it. All right, can't even see it. Maybe it's like directly in the corner, so because of that, you can't see it. Let's lower it a little bit. Let's go 410. Still can't see it. Let's make this a little bit lighter. So let's make the background 300. Let's go 220 for the background. I don't see the point. So maybe let's move it over to the left a little bit. So let's go 390, comma 10. So it should be, it should be like right up here somewhere. So let's see if that works. There we go. I see it. It's really hard to see though. Let me see if I could zoom in. Yes. It's right here, this little tiny point. Wow. So it's just like one little pixel. It's kind of hard to see actually on a Retina display. Is there a way to make the points bigger? Let me see in the reference. Let's search for point. Can we make the, okay, so we can make the point bigger by changing the stroke weight. So let us make the point, or let's change the stroke weight to 10 right above the point. So before we draw it, there we go. Now we have a nice big point in the top right corner of our preview. And what else did they want us to do? Draw a point in the middle of the canvas. Okay, so to do that, we're going to draw another point, and the middle will be, so remember our width is 400, because that's what we created on line 2. So the middle will be 200. And the same thing with the x and y axis. Since it's a 400 by 400 square, it's also going to be 200 to be in the middle. So 200 by 200. If I could type. And when I hit run, we have a point in the middle as well. Perfect. All right, draw a point near the bottom left. So same idea for the bottom left. We're going to be, so we're starting on the, we're going to start with the x, and we're not going to move that far out. So let's do point. Let's start at 10. And for the y, we're going to move all the way down. We got to move as far away from the top as possible. So we want to make it as close to 400 as possible. So let's go, I mean, we could go 399, but let's go 390 just so we could see it. So it's kind of like the reflection of this, or the inverse of that. And there we go. We have our 3 points. Draw a horizontal line, a vertical line, and a diagonal line. Okay, so let's do that. Let's draw a horizontal line first. So let me get rid of these. Let me just comment out these points. So I don't need to get rid of them, but I'll just comment them out. The way that I did that, actually, for anyone that's curious how I could comment out multiple lines, I highlight the lines that I want to comment out, and then on a Mac, it's Command / or question mark. On Windows, it's probably Control question mark, Control /. So now we want to draw, let me comment out the stroke weight also. Let's just draw a line, so a horizontal line. Let's draw it going across the middle. Let's do going across the middle first. So the x1 will be 0. The y1 will be 200. The x2 is going to be all the way on the right side, so that's going to be 400. And the, sorry, that's the x2. And now the y2 is still going to be 200. So you keep the y's the same because it's going to be a straight line. So let's run this. And there we go. We have our straight line. Let's create another line going straight up and down vertically. So that's going to be a line. And let's draw it going down the middle as well. So that is going to be the middle along the x-axis is going to be 200. We're going to start at the top. So we're going to start at 0. We're going to go to the bottom. Wait, so no, sorry. The x is going to stay the same. So it's still going to be 200 along the middle. But we're going to go all the way down to 400. And so that should draw us a vertical line going right down the middle. Perfect. And lastly, I want to draw a line going diagonal. So let's say from the bottom left corner. So let's do a line going from the bottom left, which is going to be 0, 400, all the way to the top right. So that's going to be 400, 0. And when I hit run, there we have our diagonal line going right down the middle. All right, beautiful. So the thing about JavaScript that I kind of don't like now that I've come back to JavaScript from Swift is that in Swift you can have named parameters, named inputs. So I could do something. It would look something like this, x1, y1, and this is much more readable. x2 and y2, let's say. Wait, I think I deleted. Oh, I lost the you could have named parameters like this in Swift, which is really nice. But the only problem with Swift is that you kind of like need to be able to use, you need to have a Mac basically to use it right now. So it would look something like this. So someone reading this code could just see, okay, look, it's the, the x1, the input for that is, the argument is 0. For y1, it's 200. I mean, right now I'm getting a lot of issues because this is not JavaScript. This is Swift. But named parameters are really nice in Swift. I think tomorrow or the next day, whenever I stream again, I'm gonna do some Swift because I kind of miss it now. I've gotten used to it, and it's like when you go from language to language, it's kind of hard to go back and forth. You kind of forget what you're doing with one of them. Okay, so we did all of these 5 practices, and we are at 4 hours so far. Okay, why stop there? Let's keep going. There's some extensions. Use multiple line functions to create a rectangle and a triangle. So the lines create a house. So pentagon. Add comments for each line. In P5, you could use variables width and height that are always set to the width and height of the canvas. Okay, so is that built in? Would I be able to just do that? Oh, that might work actually, right? Yeah, I mean, these are all 400 is the height, which is also the width, but yeah, okay, it's built in. Cool, Mark. Same thing here. Although I'd probably name it. I'd probably use the width when it's supposed to be the width. But that's great, awesome. Cool, built in. All right. Let's see, the third lesson. We'll probably go through Unit 1 today. Rectangles, ellipses, and layering. Is this an entire unit? Or Lab 1? No, we're not going to go through Unit 1. Unit 1 is, we'd have to do all these. We're just going to go through Lab 1 today, probably. I'll see if I can go a little bit faster. Maybe not, we'll see. Okay. In this learning activity, students will create a visual composition using the P5 shape drawing functions Rect and Ellipse. So we're going to get more practice with Rect and Ellipse. Continue to build on the understanding of functions and their parameters to recreate the robot from lesson 1. Once again, we got to be able to consult the reference. All right, blah, blah, blah. We have some student outcomes here. Once again, these are the computer science concepts that the teacher should be able to get the students to understand by the end of this lesson. Let's see. Let me close out this worksheet as well. Okay. The Rect function takes 4 parameters: x and y position, width, and height. X and y values refer to the location on the canvas, and the width and height refer to size. Okay. Now, to help you place shapes where you want them on the canvas, you can add the following line to your code. Mouse x plus comma plus mouse y. What does this do? To help you place shapes where you want them on the canvas. Let's see how that works. Let me comment all that out and just put that line, the text line. We have a lot of commented out code. Oh, okay, I see what it's doing. So this is just constantly reporting back where my mouse is. Pretty cool. And it's at positions 20, 20. So if I wanted to move it over just a little bit, I could probably do 5, 20. Yeah. So there we moved it over just a little bit. We can move it up also. We can make it like 15. Let's see how that looks. Yeah, it's right in the top left corner. Okay, so that's cool. That's neat. So the bottom right-hand corner would be the maximum width, or the maximum x, and the maximum y. So it's 400 by 400. And wow, I can go off this canvas all the way down here. Okay, pretty neat. Okay, what next? In the P5, shape and color functions are rendered to the canvas in the order they're written in the program from top to bottom, okay? This function runs in a loop. So the draw function, yes, we learned that in the beginning when we were trying to get that circle to, like, you know, create a trail of circles. We learned that it just kept redrawing draw. So we didn't want to cover up the background. We didn't want to have the background over and over again because it was just like delete everything that we were trying to draw, the trail of circles. The shape is drawn first, the shape is drawn second. So I wonder if it puts a shape on top of the other if it's drawn second. That must be how it is. Play with the order of the shapes here, then remove the contents to see how the rectangles layer on one another. So let me run this. And let me just, so the ellipse should be on top. Yep, because it's going from top to bottom. So anything on the bottom of the code will be on top in the preview. And if I was to reverse the roles here, then we'll have the rectangle covering the ellipse. Okay, that makes sense. I'm understanding the layering system here. Recreate the following sketch using rectangles. So we're going to have 4 rectangles. I mean, I think that'll be pretty easy to do. Let's do it. What am I waiting for over here? So we have our background. Let me just restart this over. So we are going to start with a rect that is going to be at position 0, 0. And it's going to have a... And right now I think it should be in like the corner mode. The rect mode will be corners. So the top left one will be easy. It'll just be at 0, 0. And then we'll make it, I don't know, 100 by 100. It's kind of big, I think. Yeah, let's make it smaller. Let's go 50, 50. There we go. Okay, so we want to create another rect, and that is going to be, so along the, we'll do one on the top right first. So that is going to be at 400, but we don't want to go all the way. So we want to go 350 because we're going to make it 350 wide anyway. So 350, and same idea. We want to start at 0 at the top, and then we want to make it 50 by 50. And there we have our rectangle in the top right corner. So I just like, you know, if you say it out loud, if you get stuck, that's just the way that I kind of like, you know, get used to doing this. Let me think if that's, yeah, that's fine. Now for the bottom left, we're going to do another rect, and that's going to be at 0 along the x-axis, and then not 0, and not 400. We're going to go 50 up because we're going to make the box 50 pixels tall. So 350, and then we can make it 50 by 50. So that'll make a square in the bottom left, and in the bottom right, we want to make our rect. And that's going to be, again, 350 along the x-axis, 350 along the y-axis, and then 50 by 50. Let's draw that. And there we go. We have our four squares in the corners for this, for that. Okay. Oh, they want us to draw 4 squares in the middle also. So there's a couple things we could do here. We could draw the four more rectangles in the middle, or we could draw one big rectangle, one big square, and then draw like a line from a line going vertically and a line going horizontally. I think I'd rather just do 4 squares. I think. So let's do that. So we're going to do 4 squares. I'm just going to start it off. So the first one, if we want it to be in the center, and it's going to be 50 by 50. All right, so we got to do all this math. So it's 200 minus 50. So we got to make it 150 along the x, and then we got to bring it down. So same idea. 50. Sorry, the middle would be 200. Subtract 50, and so it's going to be 150, and then 50 comma 50 will be the size of that rectangle. Then the one to the right of that will be, instead of 150, it's going to be 150 plus 50. It's going to start at 200. And coming down, it's also going to be at 150. 50 by 50. So that should be right next to it. Good. All right, the one below it will be, let's go like across the line. So we're going to have another one that is going to be at 200. No, sorry, at 150 on the X, at 200 along the Y, because it's right in the center, and then it's going to be 50 by 50. And then the last one will be 150 would be here, 200 would be here. 200 along the X, 200 along the Y, 50 by 50. There we go. All right, so that is how we get, or that's how we draw the exact same thing that they have here. Let me see the solution just to make sure that I'm not doing anything weird here. Mine's a little different, but it's close enough. I mean, wait, why is there an ellipse? Why are they drawing an ellipse? Let me see what the solution looks like. Oh, they have a circle in the square? Did I not see that? Oh, right here it says draw an ellipse. The parameters are the same as for the rectangle. So we want it to be in the space where the rectangles are, I guess. And then we could do circles in those squares also. So, I mean, this is a fine challenge, but I'm not going to do them right now. I don't see the benefit of practicing this right now. To me, it would be the equivalent of like a 9th grader practicing like their, 2 plus 2 and multiplication tables. They're single-digit multiplication tables or something. I'd rather just keep going and trying to like absorb more new stuff, more new functions and stuff like that. Hello, man. What is this? So this is called P5. It's a JavaScript library. And I've seen a lot of people using it. A lot of people have been talking about it. Teachers are using it. Students are using it. So it's to use JavaScript in the browser, but use JavaScript almost like Scratch or like Snap. Something about humans. Hello. So I'm just going through like one of the curriculums for teachers that they would be presenting to their students, so I could get some experience with P5. Because before today, I literally played around with it for like 10, 30 seconds maybe. I think I opened it once, and I was like, all right, forget this, and then I just left. So today I'm getting a much better idea of what's actually happening here. Yeah, so this is JavaScript. So there are some functions here that are abstracted away from the user. So Rect, for example, it's not a built-in JavaScript function or method. But this is a library. So there's code behind the scenes that understands what Rect is and what all these inputs are and what they do. So something about humans. The reference document here, there's like a lot of things that JavaScript can do with this library, or that you can do in JavaScript with this library. Let me go to the reference here. There's a whole bunch of things on colors, shapes. You could do 3D stuff. You can do a whole bunch of different things. They have some really cool examples, actually. Let me go back to the examples and show what they have. They have some like science-y kind of stuff here, like physics stuff. They have clocks, mouse detection. It's like a visual JavaScript kind of a thing. I think that's what it does. It makes JavaScript more of a visual language. Whereas when I use JavaScript, it's really going to be like text-based, or like I'm like playing around with the command line. This allows you to create stuff for JavaScript in the browser using the methods of the library. So it's pretty cool. And these examples, I would definitely recommend checking out these examples. They have the snake game, it looks like. Can I control it? How do I control this thing? Why is it not letting me? How do I change the movement? Oh, I, J, K, and L. I, J, K, and L. Okay, so I mean this was created with P5. So it's to do this in JavaScript without a library, like a library that makes it easy to create like shapes and do visual stuff, it'll be a lot more work. So this kind of abstracts that away from someone who's just learning JavaScript or doing stuff with JavaScript. So let's see if, Hold on, I gotta first run it, and then I could use. Why are my keys not working? Once you click run, click anywhere in the black area. Okay. Okay, now I can control it. So you have to click in the canvas. But the cool thing is that you could see how this was created. So Snake is a game that we used to play in high school like a lot. And the snake gets longer as you like obtain more of these like apples or something, or dots. So that you just got to be careful, because you cannot touch, you can't hit yourself, otherwise you lose. So right now my score is 10. I've picked up 10 of these things. But this is a pretty cool game that was apparently created with p5.js. So the cool thing is that you could look at the code and see how they actually created this. So you could recreate this in Scratch or Snap or another language. I went around and like hit the right arrow key and hit myself. But this is awesome. This allows you to see the code of how this was made. So let's see. So this is how you could switch directions. Really cool stuff. So you could do some pretty cool stuff with this, apparently, with JavaScript in the actual browser with this library. You could do some, I mean, there's a lot to do. A lot of these examples I would highly recommend you play around with or check out. So I saw some of these examples. Some of them looked pretty crazy. I mean, look at this particle system. This is like really advanced stuff, I would say. In terms of like the math that's going on behind the scenes, to write this code is probably not an easy thing to do, to come up with. So, I mean, some of these things have been built with P5. So I think it just shows like the power of this library to be able to create this kind of like particle effect. Okay, so I've just been playing around with one of the curriculums that teachers can use with their students to kind of get an idea of like how P5 works. Because I really didn't know anything about the canvas or this draw function, that this is like continuously running. I didn't know anything about P5 really till today. But I've heard a bunch about it, so figured I'd get some practice with it. Using code, draw the robot that you made on graph paper. You can use this starter sketch that contains the following: the mouse canvas position indicator and an adaptable grid. Let me see what they're talking about here. Let me close that. Let me run this code. Okay, so this created like a grid, but what is how do I draw the square? Oh, they want me to draw the robot on here, so that I could like actually see it with these little lines inside of it and stuff. All right. Once again, I'm just gonna skip through that. I'm gonna keep going. Can you figure out how to draw a triangle? 3 lines, and make sure that where one point ends, another begins. All right, so that was lesson 3 in unit 1. Let's see lesson 4. How can you use shape functions to create images? Okay, so let's see. In this activity, students will create a visual composition using various P5 shape drawing functions. They will continue to build on their understanding of functions and their parameters to recreate the robot from lesson 1. All right, so that robot, it just does not go away. It just keeps coming back. Students will be able to consult the P5 reference, create triangles, quadrilaterals, arcs, so on. Okay. All right, so let me get to the good stuff here. Let me see the shape guide before I skip something that might be really helpful. Oh, so we can draw a triangle without 3 lines. We could draw it with just the triangle function. That's pretty cool. Going to come in handy. This is how we draw a polygon: begin shape and then put the vertices for the polygon, and end shape at the end, close it. Interesting. All right, While it's great to place shapes on the canvas using built-in functions, we're going to learn a shortcut in order to help us draw more complex shapes to make more interesting drawings. First, because this activity will have you problem solving, we must go over what to do when feeling stuck. I mean, you all know what I do. I just talk it out loud, Google search, and let's see what they suggest. Ask yourself what was supposed to happen, what happened instead. If there's an error, look at the line number in the error description. If the error message has a suggestion, try that first. So they must have like some error detection inside of P5 also. Check for common errors, play with the code, use teamwork, check out the P5 online reference, okay? Change the shade and stroke of your shapes. You might have noticed this. If you don't change anything, your shapes are drawn with a white fill and a thin black stroke. So that's the outline of the shape. But you can change them using the fill method and the stroke functions. When given one parameter, fill is set to a shade of gray between 0 black and 255 white. To get rid of the stroke, add no stroke, and to get rid of the fill, add no fill. So then it would just be like the outline of the shape without any color inside of it. So I guess it would just be transparent. You could also change the thickness of the stroke by adding stroke weights. Remember that since the code runs from the top down, when you change the fill or stroke, that change will apply to all of the code beneath it. It can be useful to compare the program to a person drawing from instructions. You might instruct a person to pick up a white pen, draw a square, switch to a gray pen, draw an ellipse, draw a line. The square would be white, and both the ellipse and the line, as well as anything else you tell the person to draw, would be gray until you tell them to switch pens again. Since the code runs from the top down, it will work the same way. If you add a white fill and draw 3 shapes beneath that line of code, all 3 shapes will be white. Play with the thickness of the stroke and the shade of gray here. Okay, so I understand what's going on. I understand what they're saying. If we run this, we can see what's going on here. So this fill 100, if we make this 0, it's going to be a black circle, I'm assuming. There we go. If we get closer to 255, it's going to be white. So if I make it like 255, it'll be actually white. There is no stroke, so there is no outline along that. Or I could do stroke weights and change that to 10, and then we'll see a dark black outline around that circle. Or we can make it a little bit thinner and just make it like 1, let's say. Let's see for this square in the middle. They picked the color of the stroke to white by doing stroke 255. They made it the stroke weight 5, and then they drew a rectangle inside of it on top. Okay, that works. And then they have the line all the way on the right side. So I can make this line thicker by changing the stroke weights, and now you can see that it's a bunch thicker. And I can also change its color, make it 250, and it'll be close to white. All right, I understand the way to draw these shapes and stuff like that. So let me leave that page. Let me go back to the instructions. Oh, I think my computer froze. Not my computer. I think my my Safari froze. Uh-oh. Let me see if I can go to google.com. All right, so that still works. What happened with the rest of this? Maybe one of these browser windows or tabs got maybe had an infinite loop or something going on. Yeah, I cannot go back to what I was looking at. I can't even close these. Wait, I can close one. Why is this happening to me? That's all right. Let's go back to the 1.4. Let's just reopen it in another browser window. Looks like we're stuck. Let me open up a new window, and we'll do this again. We'll try this again. 1.4 various shapes. All right, I'll close out the old one. And we'll put this as the new one. Okay, let's see, where was I? The square would be white. Okay, so I did all that. Triangle using the triangle function. So I haven't done a triangle yet, but I understand how it works. Quadrilateral, and then the polygon you could do with begin shape. So I understand all of those. Oh, do they just want me to do that right now? Create the following shapes. Oh, so they want me to recreate these shapes down here. That's interesting. Okay, so let me open up p5.js. Let me open up the web editor. All right, we could, actually this is kind of tricky. How am I gonna, all right, the canvas should be 600 by 120. So let's make that first. 600 is gonna be along the X, and 120 is going to be the height of the thing. There we go. So we have a triangle first. I'm just gonna draw any triangle. Triangle. Let's see. We'll have it at, I don't know what this is. So from the Y, it's going to be around, I don't know, I want to say like 80-ish. Maybe 60 pixels from the X, and the Y would be 20. 80, 20. And the next point would be, along the X, it would be about, let's say 100-ish. And if we go further down, like 60. 100, 60. And then for the final point, it'll be to the left. So it'll be like maybe, instead of 60, it'll probably be closer to, sorry, instead of 80, it'll probably be closer to 60. And then it's further below everything else. So we're going to get as close to 120, or closer to 120. So let's go with 110. Let's try that. Let's see what that triangle looks like. It looks a little warped. Maybe I went too far down. So maybe we'll go 90 instead of 110. I mean, it's not a pretty looking triangle, but it's a triangle. That'll count. Hold on one second. I'm getting a bunch of texts. Okay, no problem. Thank you. So here we have this weird shape. Let's see. It's actually really interesting because it also doesn't close. So I guess what we could do is, what is this? How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, this is gonna be so annoying. I really don't feel like doing it. But I think what I would do is I would draw everything, all the vertices, all these, you know, I would start the shape using this, no, not this one. Where was my reference that they shared with me? The shape guide. I think I would use this start shape method, begin shape, sorry. And then draw the vertices, each of the vertexes or vertices. And then just before the last one, I would do no stroke. So that way it doesn't close it off with a line. I think that's what I would do just before the last point. And then it would have all 10 points. But I really don't feel like identifying all 10 points right now. It just feels like a lot of time to spend on that I don't want to spend on that right now. And then the same idea here. I mean, this one's 1, 2, 3, 4. So this is a quadrilateral. This one's a lot easier. It's like almost like doing a triangle, but we add 2 more points, 2 more x, y coordinates. The last one would be a little trickier. Kind of looks like a pizza. How would we do that, actually? We could draw an ellipse. Actually, I don't know how we would do that. Let me think. Well, it can't be a straight line. No, it's not a straight line. How do you draw this curved line like that? Did I miss something when we were reading this? Oh, create an arc. So how do we create arcs? Did they ever mention that? Let me search for arc. Here we go. Oh, it's really weird that they would. Well, I guess this wasn't these weren't the directions, but underneath all this, we could see how we could draw an arc. Right over here. Arcs are part of ellipses or circles. To draw an arc, we need to specify the start angle and end angle of the portion of the ellipse that we want to draw. Okay, so it starts at 230, 90. The length is 200 and the width is 100. The start angle is half of pi and the end angle is pi. Okay. Interesting. I'm trying to think why we would need that, but I mean, this is pretty intense for, what grade is this supposed to be for? This must be middle school, like upper middle school, like maybe 8th grade. Yeah, this must have been 8th grade. This is like 8th grade stuff, I think. When you learn this in 8th grade math, it would be nice to do this, to go from radians to degrees and understand how to do that in P5. But we could choose to use degrees instead of radians also, which might be nice. Okay, they have a cheat sheet if you prefer, if you get stuck on that. Down here they have the reference material. So it's nice that they provide all these like reference materials so that, you know, if you don't understand some of this stuff, you could like figure it out. I actually really used to hate this in math, now that I think about it, back in the day. All right, so we have our sheet. And once again, I'm not going to spend the time like trying to figure out how to draw an arc. I just want to keep going and finish up Unit 1. So wait, where am I? Unit 1, the final project, or the final thing, is a mini project. So we did all the 4 other lessons in here. Let me go on to the mini project. The Taijutsu symbol, or the yin-yang over here. Yin and yang. Okay, how would we draw that? That is actually really interesting. It consists of 2, 1 black and 1 white swirling teardrop shapes. Yes. That fit within each other to form a perfect circle. Okay. Use shapes that we covered in this unit. Add comments to the different shapes. Use fill and stroke to change the colors of the shape. Actually, so I can kind of see what they're doing here. You can kind of see that it looks like they used a circle to start it at least. Down here, the same thing. They have like a black circle. They have 2 circles. Maybe it's just 2 circles, one on top of the other. All right, so let me back out and think. So we have a white circle, we have a black circle, we have a black circle inside of the white circle, and we have a white circle inside of the black circle. So that's how we get that. And then to do the rest, I guess we have 2 arcs, like one along the left that's filled with white, and one along the right that's filled black. And as long as we have the circles in the right positions, then we're going to have the, it'll display correctly. So that is really interesting. I'll start it off. I'm probably not going to finish, but I'll start coding what I'm thinking. Oh, wait. No, we have to create our own symbol or do this, recreate this one. Use shapes that we covered in this unit. Center it in the middle of the canvas. I guess I think they're trying to get us to recreate this. Oh, the extension would be to create your own symbol using the shapes that you've learned. Okay. Let's try our best here. Let's create a canvas that's, once again, it's 400 by 400. Let's just make it white. So the background will be 255. Okay, let's remove this triangle. I'm going to need two circles, one on top of each other. Okay, so let's make these circles, let's say, so that is the ellipse. Let's start at 200 and bring it down by, let's say, 100. And then we'll make it 100 by 100. So this should be my first ellipse. Actually, I should move it down a little bit more. So let's go down to, not 200. This will be 200. Oh no, I don't want it in the center. So let me offset it by 50. So the radius of that. And to put one directly underneath it, I'm going to draw another ellipse. And that is just going to start at 200 and then, so let's see, 200 along the x. Then we have to go down, I think starting at 250 and then 100, 100. There we go. So we have the two circles. Then we need two smaller circles in the middle of each of these. We'll worry about that in a little bit. Let me just get one of these ellipses to be black. So will that work? Is that how I could, no, that's not. Let me fill this top one with a 255. Actually, let me make the background 220, so it's like a light gray. There we go. All right, so what I have to do is I have to make, this is gonna set my first circle as white, and this one's gonna make it black. Okay, so now I'm gonna have to put ellipses inside of each of these. And I don't want a stroke on the top one. So how do we do that? No stroke, is that what works? Yes, so no stroke. Actually, no stroke on either, because you know the all black one, it's already filled. So that's good. Okay, so now we need an arc to go from the top of one to the bottom and go along the left side. Now before we get to the arcs, why don't I just put the small circles inside of the middle? Actually, how do we draw? I don't feel like doing all the math in my head right now. So what I want to do is I want to be able to, where's the text? There was like a text function that allowed me to see how far, like where my mouse was. Where is it? Oh, here we go. All right, so I want to have that on the screen actually, because that'll make my life a lot easier when I'm trying to find the points of these things. So let me just restart this. All right, so my little circle will be around 200, 150. See, makes your life a lot easier to not have to do the math. Okay, so my little circle, we'll draw that after the black one. So we're gonna do a fill, and we're gonna make it black. Actually, no, we could continue from here. We're gonna just make another ellipse. And this one is going to be, was it 200, 150, and then we're gonna make it smaller. So we'll go, let's say 50, that might be a little bit too big. Let's go 40, 40. So this should draw a small black circle inside of the white circle. Something went wrong. Oh, I misspelled ellipse. Ellipse, there we go. Okay, way too big. Let's make it a bit smaller. Let's go 20. That's better. And now I want to draw the white circle inside of the black circle. So that's going to be at 200, 250. I'm going to draw that when I do the white one. So ellipse 200, 250, and then it's also going to be 20 by 20. Oh, what happened? Oh, you know what it is? It's being, I also misspelled it, sorry. Ellipse, if I could spell correctly. But it's not showing up because I think it's being covered by the black one. So we have to draw it after the, first we have to change the fill to white, 255. And then we could draw this circle underneath. There we go. All right, so we're getting there. We're getting somewhere. Now we need to figure out how to draw the arc. So from the top of one to the bottom of the other. So I guess I got to go back to the reference manual here. Okay, so let's see how we can draw this kind of a shape. So can I copy this? No. Oh, this is going to be so annoying. I mean, we could pinpoint where to start. That'll be actually center of the ellipse. We could identify its center. That'll be easy. Start angle, end angle. Let's try creating this. Center of the ellipse. Okay, so the center of our ellipse is going to be at 200, 200. So let's go back to arc. 200, I mean, you could see how, like, without comments, this is just like really dirty code. Like it's really nasty to look at. Like I mean, I wouldn't wish this on anyone, to just have to look at this code and try to figure out what's going on. I mean, I really should be commenting like crazy, but I'm kind of lazy right now. All right. Center of the arc is going to be 200 by 200. Let's see what else. The length and the width. How do I know the length of this arc? I mean, let's start off with. Let's do 100 by 100. Let's see what happens. Let's go from there. Let's guess and check, I guess. Let me close that. So this is what we're trying to create. We're trying to create this yin and yang symbol here. Start angle. So I'm assuming that's going to be the top. It's going to be 0. And then the end angle. I mean, how can we end at the bottom? Let's do this pi plus half pi and see if it ends up where, like, in the, like, as a 3/4 of a circle. Pi plus half pi. Pi plus half underscore pi. Let's see what happens. Okay, so actually let's we need a stroke again. So stroke. Let's just get a stroke width going just so we could see this of 1. Why isn't that working? How do I use stroke width? I guess I got to go back to my a stroke weight. That's what it is, not stroke width. Stroke weight. And it did not draw anything. It didn't actually draw the stroke. Oh my goodness, this is annoying. And actually, we got to make this bigger. So instead of 100 by 100, maybe 200 by 200. Does that work? Yes. So that is the right size. We don't need it to go all the way back around like that. So maybe we could do, what'll be the end angle? Will it be pi? No, it'll be a half pi. Oops. No, why is it doing that? All right, I'll have to figure out that math in a little bit. It's been a while since 8th grade, so I'm gonna have to think about that hard in a few minutes. But for now, we have to remember that this is right now. It's like layering this on top of everything. And that's not what we want. We kind of want to, actually it's not even doing the stroke weight correctly because I don't see the outline of it. But that's okay. I don't really care about the, let me see what is it the left side that's white? No, that's not it. No, the right side, the left side is white. Either way, depends on how you're holding it. Okay, so that's okay. So we could put this before the black circle. All right, that's good. So now what we really have to do is we have to get this to just draw half. Right now it's drawing 3/4, And the last part will be, we have to draw another one of these, but we'll make it black. I mean, right now, could I do fill 255? Is that black? No, fill 0 is black. Yeah, so this will make it 255. So that'll be white. And then we'll do another one that is black, but we'll do the black one after the white. Actually, will it matter? This is the annoying thing about reading code top to bottom and having to make sure that it's in the right place. Okay, well, I can't do this right now because then it's just overwriting exactly what I had just before. All right, how do we get it to just draw half of a circle using the, the radians correctly? Okay, length and width, that's fine. 140 by 140. Start angle is 0. Wait, do I have it at 0? Yeah, start at 0 and go to pi plus half pi. How do I get it to go to the bottom? So what's that angle? That angle is 180 degrees, which is pi. Maybe if we start at pi. All right, now we're guessing here, but let's see what we can do. Start at pi and end at 0. Let's see how that looks. All right, we're drawing the circle a little bit, not the way we want it. What if we started, no, but if we started 0 and go up to pi, that's going to be the other side, the bottom. All right, we're just going to have to keep guessing until we get this right. Why is it doing that? 2. Maybe we'll do 270. So 270 will be pi plus half pi, and then the bottom will be half pi. So let's try that. Half pi, and then we'll do pi plus half pi. There we go. Okay, that's half the battle. And now the other side, we'll do pi plus half pi, going all the way up to half pi. Okay, but we need to make sure that we put this underneath the white circle. So why is that? So that should be before the white circle. So I'll put it up here. Let me just clean up my code a little bit. There we go. There we go. We did it. All right, so as long as that's before, that's after, and then this is good. I mean, it's good, but it's really nasty in that someone reading this would have no idea what the heck's going on. So, so even though it works, it's not very, it's a little dirty. But we got our yin and yang working here. So, so that's kind of cool. That was kind of neat. And you got to see me struggle with Radians over here because I haven't done Radians in forever. So what I just did was I looked at they have the little chart here that shows you in degrees how to convert that to radians or to p5.js. So when I saw that I needed to go from like, let's say up here to down here, so I could see that was at 270 degrees all the way up to down to 90 degrees. So over here, if you look at the conversion, it's pi plus half pi, and then for 90 degrees it was half pi. And then for the other way, to go from 90 to 270, it's half pi to pi plus half. So just the other way around, the inverse of that. So yeah, that's how I got that working. I didn't know it was called the taijutsu symbol. I always just said like yin yang symbol, yin and yang. Let's see. Oh, there's more stuff in the reference material. If you're trying to draw like another weird looking shape, like a circle that has like a straight line going through it, you could also do that. A line segment there. All right, and that's it for the that material. Oh, let's see what else. Create your own meaningful symbol, like the taijutsu. It should have meaning. Let me just, I believe it, but let me just Google it. Let me just Google taijutsu. Yeah, it's a symbol or diagram in Chinese philosophy representing Taiji. Okay. All right, so we'll go with that. Ooh, I've never seen this one. It kind of looks like the Chrome symbol, a little bit. All right, so we were just able to create that with P5, and to do this without, just pure vanilla JavaScript, like on our own, this would be pretty intense. We'd have to figure out a lot of things to do to get it visual like this. So P5 is pretty nice in being able to use JavaScript and like get up and running pretty quickly. I kind of like it. I wonder what is in Unit 2, what we would have to do next. What's available to us? So, not Unit 2, sorry, Lab 2, or Lesson 2, I guess. And that's not Lesson 2, it would be Lab 2. So I guess we have units and then we have big labs. We just did all of Lab 1. So Lab 2 is called Make It Vary. So what happens here? So we use built-in variables. Okay, so here's where I would probably learn what Mark was talking about before, where there are built-in variables of height and width that I don't need to create because they already exist in here. And the mouse X, mouse Y. Oh, that's pretty cool. So I could scroll also. I mean, maybe that's not cool. Maybe it's just it creates a small little window and I could scroll through that little like frame. Okay. But this last challenge was not. This is not for the faint of heart, I don't think. I think it would require quite a bit of math understanding to be able to do that as the first lab. Like if a student just learned how to code for the first time. This would have taken probably a bunch of days to get to this point, and I just did it in like 2 hours. But I'm trying to think how this would work in a classroom. So I'm trying to think like as a teacher, how I would go about like presenting all this stuff. I feel like this has like a lot of mathematical. It has like a good mathematical foundational kind of thing. If you're a math teacher, this is like actually kind of fun stuff. But I wouldn't say it's easy for like, let's say a 6th grader, or definitely not a 5th grader. I mean, that's just not, I don't think they would be able to handle that. Custom variables, final projects. Okay, so this is all in Unit 1. How many units are in this entire curriculum? Unit 1, Unit 2. So Unit 2, you can see we start doing conditionals, if statements, stuff like that. Unit 3, we have loops, arrays, images and arrays with ML5. Are they doing machine learning in here? Training models from scratch is well above the scope. Okay. Well above the scope of this course, so most of that is given in a code along. Okay. Let me search ML5. So it makes machine learning approachable for the web. So I've heard of TensorFlow. Yeah, TensorFlow is right over here. It's a high-level interface to TensorFlow. So this could be better. It's probably more approachable to someone who has JavaScript experience, but isn't ready to like do some like real machine learning, like complicated stuff. But the cool thing about machine learning, it's like, you could train a computer to identify like let's say cat in pictures, or to be able to detect what a character is in like instead of doing optical character recognition, you could like just like train it on a model of a bunch of different characters, and it can identify what the character is using machine learning. So that is so cool, actually. And then it could create its own doodles. Oh, that is awesome. I'm really interested in this curriculum now, like to get to this point. Or maybe I would do it on the side or something. I want to see like how deep they go, because I'm interested in this kind of stuff. Because I haven't done any of this. I'm interested in it, but I haven't done any. I haven't like gone into it at all. So I've been more focused with like building like little tiny apps and things that I could run on my phone. Just like a simple app, nothing too crazy, but it seems kind of fun. Unit 4 is motion. Unit 5 is functions. Unit 6 are objects, constructors. Okay, this is good. This is good stuff. Unit 7 is the DOM. And that's it, Unit 7, up to Unit 7. So, I mean, there's a lot there. There is a lot to do in this. And I know Coding Train, this guy, Daniel Schiffman, I know he does a lot of P5 stuff. He really loves P5. And he's done some really, like, he's got a really good personality. He's like a really interesting dude. I actually met him once. He let me use his studio, me and one of my coworkers. He let us use his studio to create a video that we were making for our team. So he was a really nice guy for letting us do that. And I know he makes some like really good videos. And they're always long. This guy live streams, and he'll do like 2-3 hour live streams, like it's nothing. Whereas I'm over here struggling to stand up and to speak because I'm losing my voice already. So that's kind of funny. All right, let me close out of that. Let me close out of the project that we created. The web editor, we are, all right, we created our thing. There's our code. If you're just joining in, or if you're just seeing this now, you could see the thought process and see like the struggle I went through to create this. I'm gonna close out of it. We're just gonna leave, say goodbye to it. And that's pretty much it. I think if there's any other questions regarding P5 or this introduction to computational media, I mean, it seems like it's probably a very fun curriculum as a student. I'd have a lot of fun with this in like 8th grade, maybe 9th grade, where it's like completely different than other stuff I've ever done. Or maybe like combining art, math, and computer science is it's really interesting. Let's see. Doesn't seem like we have any other questions. So if that's it, I'm gonna probably end the stream in a couple of minutes, or maybe a minute or so. Let's see if there's anything else. Okay, so the final project for the first unit is this abstract album art thing, which is nice. I mean, if you're a musician, if you're like musically inclined, you might be able to use P5 to create your album art. I'm assuming that these are like real album covers that artists have used. And yeah, I think we'll leave it at that. I'm trying to think of what we'll do tomorrow. I don't think I'm going to do P5 again tomorrow. Maybe we'll save it for like next week. We'll continue on from where we left off. Let's see. I think tomorrow I'll probably do Swift. So I'll probably create a little tiny iOS app. So if you're watching this and you're interested in how to like create an iOS program, like an app on your phone, maybe tune in tomorrow. And I will work on that, and I will show you how to do it from scratch. But it's a little bit tougher. It takes a little bit more background knowledge, I would say, to know what you're doing when you're working with Swift. But yeah, so we'll do that tomorrow. And I don't know, we'll see. We'll go from there. I can't plan out too many days in advance because I have no idea what I'm doing every single day. So we'll just do some Swift tomorrow. And today we did P5 JavaScript. All right. We are at 4 hours, 59 minutes, and 20 seconds. I guess I'll fill up the next 40 seconds with, I don't know, some random thing. What can I talk about? Oh yeah, it's my birthday. So this was my birthday stream. If you are there, thank you for joining me on my birthday as I stream pretty much by myself with a couple of viewers. creating this yin and yang symbol, basically. Thank you, Mark. Thank you for joining again. Thank you for helping out and like mentioning P5 and glitch. It was good to see those things again. It was nice to play around with it. So now I have a little bit of a better idea of like how someone would go about using P5. All right, so there we go. We hit 5 hours. That's good enough for me for today. So I'm going to pull up my terminal so you can see that it's still going. The timer's still going. I'm going to stop it right now by hitting Control-C. So it should stop on the screen, and I will continue tomorrow. So if you want to join tomorrow, feel free to. I should be back around the same time, like after 5:30-ish, depending on when I stop working. So then I usually just eat and then relax a little bit, and then I start the stream. So probably around 6 o'clock, I'll start the stream up again. So I will see you all tomorrow. Have a good night. Bye-bye.